Thank you all for coming. This is our SIG Auth deep dive for this year. So we got a lot of stuff to talk about, so I'm going to try to keep it brisk here. So I'm Mo Khan. I'm one of the tech leads for SIG Auth. The rest of the leads are either in the audience or going to be shortly on stage. I'll introduce David, Jordan, and Micah since they're not presenting today, but leave the rest to introduce themselves when they get here. And to help us present some of these, we have some good community members who I'll also ask to introduce themselves when they come on stage. But yeah, when I said a lot of stuff, we have a lot of stuff to talk about. So we'll go into detail, but not too far. So this year we're going to do it a little different. We'll talk about the stuff that's coming up in 135 first, because the list is shorter. So I'm sure everyone has at least at some point used Kubernetes impersonation. So this release, we implemented, Zhang and myself, a new concept to it called constrained impersonation. So traditionally, impersonation has been sort of all or nothing, right? You can say you can impersonate Rita, but you can't change anything after the fact, right? So if Rita is a cluster admin on that cluster, then you're effectively cluster admin. There's no scoping beyond that. Right, so I like to use a really, really tightly scoped example to explain it, right? Which is, what if you want the service account running on a particular node to only be able to get pods while it's doing that, right? And when you intersect all the permissions through this, right, what that ends up meaning is that service account can now only read the pods for its node, right, based on how it's getting scheduled, right? So if you have a daemon set that's running across all your nodes, each individual instance of that service account is going to get a different view of the pods it can see, but all that's expressed in sort of one unified way. So I tried to stick the mermaid diagram to describe how all this works in here, and then I just gave up, because this is like a third of it. The gist of it is the whole thing is still backwards compatible. All the old stuff still works exactly like it did before. But the new stuff was so dramatically different than the existing implementation that I effectively had to rewrite it from scratch. So there's basically an if statement that says if the new thing is enabled, use the new handler, otherwise use the old handler. And so what does this look like in practice for you, the end user? Right? So if you're familiar with impersonation, it uses the impersonate verb to echo that check, right? And so now what we have done is made it so that there's two authorization checks instead of one. The first one on the top there is the one that's basically saying, what impersonation mode are you in? And what that in this case, that service account is being allowed to impersonate nodes that it's associated with. But then the second check describes, via that impersonate on prefixed verb, which action you're allowed to take, right? So you can kind of truncate that prefix off, and you can see that it's for getting pods, right? Obviously, in this case, because this is a cluster role and cluster role bindings, you could have compressed this into a single cluster role and a single cluster role binding, but I've kept it separate to sort of make it more clear in your mind that both of these checks will happen in succession, right? All right, now for graduated features.
Hey folks, I'm Rita, one of the chairs, but also SRC. Huh? Yes, sir. All right, I'm sure y'all have been hearing the word DRA quite frequently in this KubeCon and probably previous one. So this is something we work together with SIG Node quite a bit. DRA is a dynamic resource allocation feature which allows workloads to have a easy, flexible, and dynamic way to allocate, consume, and share specialized devices like GPUs and networking resources. And by default, when users use this resource claim and resource claim template, the workload only has access to the device that it has allocated to. But often, as we all know, there are admin tasks like metrics and troubleshooting where those type of admin workloads will require access to these specialized devices that are already in use by other workloads. So this is where the DRA admin access feature comes in. Before we added this feature, there was a way to do it with VAP, validating emission policies, but as we all know, that is often installed after the cluster is up and running, right? And there is no standard way where we require all the clusters to install those VAP resources. So this is why we thought, okay, why don't we add this to Kubernetes core? And with this feature, the admin will basically be able to add a annotation to their namespace to ensure that only that namespace can schedule workloads that have access to the resource claims that can use devices that are in use by other workloads. Again, this is where metrics and troubleshooting workloads come in. So great collaboration with SIG node. All right.
Hey everyone, I'm Anish. I'm a SIG Auth co-chair, and I'm also a maintainer for Secret Store CSI driver. So the first thing we have here is structured auth config. So this started alpha in 129, and as the name suggests, it's bringing some structure into how you configure authenticators in Kubernetes. And prior to this, you could configure an OIDC authenticator using flags, which means you only could do one authenticator, and if you had to make any changes, then you would have to restart API server. But with this, you can now configure multiple JOT authenticators, and JOT authenticator is an authenticator that authenticates Kubernetes users based on JOTs. And then in addition to that, you can configure multiple audiences for a single authenticator. And then we've also added cell support, which means you can do more validations, so claim validations with the token. And then you can also do user validation. So whatever final user info you get out of the authentication response, you can basically do validations with that. And then you can also use cell for like claim mappings and all of those. So this feature is GA in 134. And in addition to that, we have also added egress selector support. So you can actually configure the either control plane or cluster egress for each individual authenticator. And then in 135, we have also added like additional metrics that will help you figure out when you do rotation for like the JSON web key set endpoint and all of those. Okay, so this is not exactly a feature, but something that we tried to fix. Um, sorry. You can use cell expressions. Okay, so in about Kubernetes 120, for CSI drivers, there was a feature which allowed configuring token requests. So you can set a list of audiences in your CSI driver spec, and what that means is Kubelet will generate token for every single audience that's configured in that, and send those tokens as part of the volume mount request. But the thing that happened is there is a secrets field, and there is also a volume context field. These tokens that were generated in Kubelet were sent as part of volume context, and volume context also has other non-sensitive information with like the pod name, the UID, and all of those things. What we saw was a lot of CSI drivers log these volume context as part of the incoming request for like debugging purposes, and they did not realize that the tokens were actually present in that. So that resulted in multiple CVEs. We actually ended up having the same CVE in a lot of different CSI drivers. And so we figured, okay, like we need to solve this, and how can we do this in a backwards compatible way? So that means in Kubernetes 135, we have a feature gate, and we are also introducing a field in the CSI driver spec, which is probably going to live forever, which says that please send me the service account tokens that you generate in the secrets rather than sending it as part of volume context. And with this, basically CSI drivers would need to have an update in their logic to read the tokens from secrets and if not present in secrets, they can read it from volume context. So this should still be backwards compatible, and then it should be more secure. Since we're talking about CSI, we also wanted to give a small update on the SIG Auth sub-project that we have, which is Secret Store CSI driver. The Secret Store CSI driver enables integration with external secret stores so that you can mount secret search keys from external secret stores as TempFS volumes. And then in terms of what we have, like it supports rotation, which means if you rotate your secrets in your external secret store, it gets automatically updated in the volume mount. And we have a custom controller, which is doing that today. And we are trying to switch to requires republish, which has been a long time coming, and then we'll hopefully get the PR merge soon. With this, we'll be able to drop a lot of RBAC permissions that's required for the driver. And with this, Kubelet will periodically call the driver to ensure that the volume mount is as it's expected. Then in terms of the next feature, we have a file system ownership. So today, the files that get written, the container has to be root to be able to access it. But going forward, we would be able to configure that so that they don't have to run as root. And then we have few providers in the pipeline that are getting added to the supported provider list. We already have about 7 to 8 of them, and so these will be 2 more. And then we are also going to be implemented the fix that we talked about in the previous gap. And this is the projected service account tokens for image credential providers. It's a mouthful, but what we call it is workload entity for image pools. So this feature graduated to beta in 134. There are many ways to pull images. Like the usual way is you have an image pull secret where you configure the registry credentials and then you reference that in your pod so that those credentials can be used to pull the image. And then there are also credential providers which are configured on the node, but that also means that credential that's available on the node is accessible to every pod that's running on the node. So the thought was, what if we use the service account token bound to a pod to be able to pull the image for that particular pod? So we have enabled this so you can configure the audience for which you want a token for using the credential provider config. And Kubelet will basically generate the service account token and pass that as part of the credential provider request. And all the credential providers can use that for workload entity flows to register for, to exchange for registry credentials and send that back to Kubelet. And now Kubelet can use a credential that's bound just for that pod to be able to pull images. I'll hand it off to Stanislav.
Thank you. Oopsie. So, hello everybody, I'm Stanislav Láznička, and I like to dig around certificates and OIDC tokens and to contribute to SIG Auth as well. So one of the features that I was working on is ensure secret pulled images. It just made it to beta about 20 hours ago or so. So yeah, this group, there were a couple of people working on it with me. Actually, it was Jordan. Anish helped a lot in recently. And so what does this do? I'm not sure if you all know, but whenever you pull an image, by running a pod on a node, actually everybody who is able to schedule their pods on this node are able to access this one image. And this may seem okay for like public images, but what if the image that you are running is actually a private image from your private registry with something very super secret? You probably don't want people to be just digging around those things. And so what we did here is we built an additional authorization layer in Kubelet, which keeps record of the credentials that were used to pull an image, and then makes decisions on whether you actually can access that image or whether you need to try to pull that image again just to be able to access it. So that's this one. Now, pod certs, that's a new thing. Originally, the original implementation made it to V134. Now it is beta in 135. It's been worked on by Tahir and a new contributor, Tina. This makes it really easy for you to mount certificates inside of your pods. And you do this by just specifying a new type of a projected volume called pod certificate into your pod, into your pod's volumes. And so basically what you do is you choose a signer, which will dictate what kind of certificate this will be, right? It might be client certificate, it might be server certificate, what have you. And once you do that and you run that pod, the kubelet will look at the volume, and it will create a new object which is called a pod certificate request. And it adds a bunch of information about the pod also, so that the signer that will be picking it up later knows who is signing the certificate for. And yeah, and then it waits. So basically, the object that gets created, the pod certificate request, is then picked up by the signer from the signer name, and the signer is usually represented as a controller, which observes these kinds of objects, and it just looks at the object, and if it seems fine to it, it will issue a certificate for this object, and the certificate is eventually picked up by the kubelet, and the kubelet mounts it inside of your pod with the private key that it generated previously. Really nice feature to get some automation around certificates, I'd say. Now, restricted anonymous authentication is a feature that was worked on by Vinayak. It was G8 in 134. And usually, in your clusters, like, you are just one step away from an absolute disaster. In this particular case, so what this feature protects you from is overgranting permissions to unauthenticate users or the unauthenticated group. And the way this works is you basically specify a bunch of endpoints that you want of your kube API server that you want to be for anonymous users to be able to access, right? And that's it. Like, there's no way for you to grant RBAC permissions that would allow any access to these endpoints to authenticated users after that, because like this all happens just in the authentication layer rather than the authorization layer. All right. And with that, I'm going to give the word to Ben.
All right. Morning, y'all. Thanks for making the trek all the way over here to Building C. It's like miles from everything else. We weren't sure if anybody's actually going to be here. If we're going to be just talking to walls and, chirping crickets and all that kind of good stuff. For your reward for coming this far, we also realized we lied to you. This deep dive is like a speed run through a ton of content that's really dense, all kinds of stuff that we're flinging at you. Hopefully, we're going to get through it fast enough to leave some time for questions at the end. We'll see about that. But my name is Ben. I am a PM. I was an engineer previously. Now a PM, went to the dark side. These nice folks are letting me get up here and talk about some of their cool work. So I'm going to do a couple slides for you really fast. This first one, KEP 4940. This is PSA restrictions for probes host fields. So this is building on top of, this is the pod security admission controller, right? It's built in to enforce pod security standards. You're all probably familiar with that. The middle, a little bit of YAML there because I made this slide way dense and put all kinds of words up there for you to read. But that middle one has a label on it that says generally how this works, right? You have 3 different settings that you can use: privileged, baseline, and restricted. You put on namespaces that controls what pods can come into that namespace and whether or not they're accepted or rejected on mission, right? This particular feature is, if you look all the way on the right, is the pod spec, and that's going to say on various probes, liveness probes, readiness probes, etc., init containers, the main container, you could set the host field, right? That host field is defaulted to the pod's IP, which makes sense. So if you want to probe a pod, you're going to say, hey, is this thing awake? Is it alive? Whatever. But you could instead set that to something else, some arbitrary endpoint out on the internet, and say, actually, go over there and check that. We don't want that, right? We'd rather, with this new feature, just default to the pod IP, because this would open up to blind SSRF attacks, right? Server-side request forgery. That don't generally want to give users the ability to just ping other endpoints while it's blind. It doesn't necessarily give them directly a lot of information. It's just in a attack surface area. So this particular KEP is reducing that down on these other 2 features when the pods are not privileged. And I'm going to bump to the next one. Second one here is external signing of service account tokens. Okay, that's KEP 7740. Ooh, and I think I did not give credit on that last one. Sorry, that was Surya did this one. I want to call out people who were involved. External signing of service account tokens, 740. This, we're giving credit to Tahir, to Harshal, Jordan, and Micah, who put the work in for this one. Essentially, I brought a little prop. So you have your private keys, right? I got my hotel room keys. Boom. Do you want keys, private keys, sitting on disk next to your API server? Probably not. That's not necessarily the best thing, right? You have a lot of ways to have someone see that, log that, view it in some way, cat it out, whatever. Not the best thing. So this allows you to take your keys that you're using to sign your service account tokens and put them perhaps in a vault somewhere, right? A KMS integration through a provider, something like that. So those keys can stay where they belong, hidden away, and the tokens will be sent there to be signed and come back and then distributed to pods. So definitely a much better security posture to keep your keys where people can't get at them, right? And they're not allowed to be exfiltrated. This also allows key rotation without having to restart the API server. Another good feature that we like out of this, right? Always good to rotate your keys on occasion. That's another good security posture kind of thing to maintain. So this feature provides that as well. And that, I'm going to call it good and pass this along now to Peter, if you want to come up and take my keys back.
Thanks, Ben. So I'm here to talk about a couple of things. First thing I will talk about is the credential plugin policy and allow list that's been added to Client Go and exposed through the kubeRC. And then, since this is represents my first contribution to Kubernetes, I wanted to talk a little bit about my experience as a first-time contributor. So this was an effort that spanned multiple SIGs. SIG Auth and SIG CLI and API machinery were also instrumental in making this change. But what this feature does, the policy and allow list, is that it allows you to specify what binaries can, or I say binary, but really it could be a shell script or anything that fetches credentials on your behalf. kubectl will go ahead and execute that and fetch the credentials. Because this is specified in the kubeconfig, and because the kubeconfig can come from a variety of places, can be auto-generated or downloaded from somewhere else, you may have something in your kubeconfig that's going to execute a binary in your system that you didn't know about, and you may want to prevent that. This is a backwards compatible feature, and as I mentioned, we primarily envisioned people using it by using the new kubeRC configuration file, which is a configuration file for the kubectl command line tool. It's been separated out from other bits of configuration in the kubeconfig. So if you don't specify anything, or if you don't have a kubeRC file, or if you don't specify this field in your kubeRC file, the policy will be allow all. That's how we keep it backwards compatible. If you're curious about what binaries are being invoked on your system that you might not know about, once you get the 135 kubectl, put this in your kubeRC file, and you may end up getting an error message telling you, hey, the policies deny all, but you tried to run this binary to get credentials. If it's something you didn't recognize, you should start asking some more questions. But how we primarily see people using this is what plugin is going to run, and so you can specify the policy as allow list and then provide a second field, which is the allow list of binaries that you are authorizing to run on your behalf. It can be a base name or an absolute path. It's worth mentioning that this isn't only exposed through kubeRC. Anytime you create a client, you can set it on the REST config in the under the exec provider in the plugin policy. So you would set it to one of the three things. The policy type field would be allow all, deny all, or allow list, and then if the allow list is the policy, then you can specify the allow list. Currently, I'll go back here. We are specifying the name or path, but as the need arises, we may add other ways of verifying the binary that you want to run. For example, a digest check or a signature check. And as I mentioned, I did want to say a little bit about my experience as a first-time contributor. My first code freeze is, I would say, an interesting tour of the wonders produced by my endocrine system. But everything leading up to that was actually quite inviting and helpful. Arda from SIG CLI and Mache, what began as a conversation with them. I mean, I'm about as shy as they come, and they were extremely inviting and had a conversation, immediately saw the value of what we were trying to do. And it became clear as we were working on it that actually it wasn't just something that needed to live in kubeRC, but also something that needed to live in client Go, because it shouldn't just be the kubectl tool that is allowed to take advantage of this feature. And so that opened up conversations with API machinery. And I believe, David, you said, what are your intentions with my library? But through those conversations, we moved quite a bit closer to the final iteration of what this implementation looks like. And of course, Mo and Jordan. Jordan was very generous with his time and did a synchronous review with me and was very helpful in not only reviewing the code and making suggestions, but also teaching me a little bit about his thought process going into that. So I just wanted to say a big thanks to everyone from SIG CLI, SIG API Machinery, and SIG Auth for the help here. And of course, Mo too, for a lot of things. Too many to list. With that, I'll open it up to questions, and I'll invite other people on stage. Please come back. I'm very nervous. Questions?
Do you mind going to the mic so that the recording captures your question?
See if it's, the caffeine's in here enough to make it work. Hey, so the kubeRC changes that you were just showing there with the allow list allow you to specify either a minimal name or a full path. Is there any concern there that we might have multiple binaries of the same name, for example, something introduced that doesn't belong to us?
In that case, we would suggest the user specify the absolute path of the binary. You could specify two absolute paths with the same base name. Generally, the user is aware of, maybe this is a dangerous assumption, of the ordering of their path and which one will be resolved first.
So that was part of the question, actually, is also if you're relying on the path to reconcile possible duplicates. It sounds like that's the approach you're following.
Say that again?
You're relying on evaluation of the path to reconcile any duplicates?
Yes, and I believe now duplicates aren't necessarily considered an error, but they'll be merged in the resolution process. But yes, the path will. Are you talking about duplicate base names or?
Yeah, duplicate
Okay.
base names. Right.
Yeah, so it's going to be whatever the path resolves. It's resolved by exec.lookpath, the Go call, unless there's an exact match already in the allow list, because those are going to resolve to the same base name, so we just avoid the stat syscall that lookpath uses.
Okay, thank you.
Yeah.
Just as a quick call, I think you already mentioned this, but the API is structured so we could extend it. And if you're nervous about arbitrary path resolution, right, the way we would extend it perhaps would be some kind of signature verification, right? So only binaries that I got from like my corporate system are going to execute at all. And I think that would probably relieve any realistic concerns, right? Because the true attack vector of this is you download a kube config that you think is trusted, and it's got a shell script embedded in it, and we execute it on your machine and do whatever a shell script can do.
Hey, nice prezo. Have a quick one probably for pod certificates.
Yep.
What we wouldn't have any concerns using that with like an internal PKI or a private issuer, anything of that nature?
I'm sorry, I can't really hear too well. Can you speak up?
Sorry. Yeah, for pod certificates, yeah, I wasn't talking. I don't hear myself. There wouldn't be any concerns using that with an internal PKI or like a private certificate issuer. That would work. Okay.
Oh, what was it about the internal PKI? Sorry.
So, I mean, the way the pod certificate API is structured is by signer name. So, and it has to be like a fully qualified domain, right? So, you could use company.com/whatever the name of the signer is, and then nothing's going to confuse it with anything else, right? So the pod certificate feature is sort of meant to be used in conjunction with like the cluster trust bundle feature, where you would use the same signer name to distribute the trust for that signer. And then the signing, so whoever wants to trust it would choose to act, you have to explicitly trust it through the cluster trust bundle, and then you would have to explicitly ask for credentials from it, again, through the pod certificate mount. So no, I don't think there's any concern. It's, at the end of this, it's standard X509, so yeah, we do have plans to add built-in signers that would be provided by the Kubernetes project, but they wouldn't conflict with yours because they're already segmented by signer. So as long as you're being careful not to make one mount that somehow tries to mount a bunch of different signer CA bundles and munch them together, which you should never do. I don't think there's really any concern of using a private PKI.
Thank you.
We're at time, but is there anything after this?
Yeah, I mean, I have like a.
Yeah, looks like we are at time, but most of us will be hanging around here still, so you can come and ask us questions.
Come up.
Yeah, come talk.
Okay.
Thank you.
We're coming up.